In this video, we're going to talk about the subtropical jet stream and why sometimes when we say something is the subtropical jet, it may or may not actually be the subtropical jet stream. So to begin here, let's talk about some of the characteristics of the subtropical jet. First and foremost, for subtropical jet streams, they are typically around 200 hectopascals, a bit higher typically than our polar jet streams. This is because they are typically further to the south, i.e. the name subtropical. One of the other factors, though, is that these subtropical jet streams are much less baroclinic. And as we'll get into in just a little bit, the reason for the subtropical jet stream has actually much less to do with strong temperature gradients, and that is going to be one of the key differentiators here between what might be a subtropical jet stream and what might be just multiple polar jet streams. Typically, the subtropical jet stream is stronger in the winter hemisphere. So what we mean by this is that in December, January, February, in the northern hemisphere, it will be stronger than it would be in the southern hemisphere at that time. Typically, this jet appears around 20 to 35 degrees north or south, depending on what hemisphere we're in. So again, further to the south than our typical polar jet stream. The subtropical jet stream is really hard to identify on our classic upper level patterns. That's because this idea of the subtropical jet stream is a nearly constant flow continuously around the globe between 20 and 35 degrees north. We'll see a graphic in just a little bit that can help you see that to be the case. And so often when we say the southern jet is the subtropical jet, there may or may not be subtropical jet aspects to it, but that really could just be a combination of a second or third polar jet stream and elements of the subtropical jet stream as well. And so why do we get this subtropical jet stream that is nearly continuous around the globe? And so part of this goes back to things related to the thermal wind balance. And so the only way we can really see the subtropical jet stream is if we look at zonal time averaged flow across a hemisphere. Okay? And so we can only see it, only truly seen, if looking at zonal time averaged flow. And so we're going to go ahead and look at an image that shows this, and then we'll come back to explaining why we can still get the jet stream even when there is not as strong of temperature gradients. And so as we scroll down in this notebook here, we see here a graphic illustrating the northern hemispheric subtropical jet. And so here, our wind vectors are indicated in arrows. And those arrows you see, then the length of it indicates the strength. And so we see a pretty weak 20 to 30 meter per second jet going around that kind of like 30-ish or so, maybe this is even a little bit farther north at this time of year, jet. Maybe this looks like it's more around 45-ish or so. And we can see this nearly continuous pattern all the way through here. And again, this is averaged over June, July, August, 250 hectopascal long-term mean winds. So again, this is not something that's going to show up on your daily 250 weather map. It is something that is inherently baked into that map, but is not the pattern that you're going to see on any given day. And we can see that it is nearly continuous. Now in the summertime, northern hemisphere, it's weak. But if we look at the wintertime subtropical jet from the northern hemisphere, we see that it is much stronger, but still nearly continuous around the hemisphere. And we see it peak here at 70 meters per second out over the Pacific Ocean, 40 meters per second here, just off the east coast of the United States. And so it is easy to see how we could have, with our typical synoptic patterns on any given day, have a certain amount that is coming from a subtropical jet stream that is higher aloft in the atmosphere than our polar jet streams. But that often, what we're seeing is really a combination of both our polar and our subtropical jet streams. And so the question is, if this is the average wind over a long-term mean, basically meaning 1981 to 2010, why do we see these jet streams? And so part of it is that we don't have very, very strong temperature gradients always at this location. So we can't explain it just by saying, oh, hey, there's strong temperature gradients there. Now, there are some temperature gradients. And so it happens that our subtropical jet is the result of planetary scale processes. And around 20 to 35 north, we will have shallow areas of small temperature gradients. But not nearly enough temperature gradients to associate with, say, 70 meter per second winds. And so how do we get small temperature gradients that result in strong shear of the geostrophic wind? And it turns out that at low levels, or at lower latitudes, we also have low values of Coriolis parameter, F. And it turns out at 20 degrees north, for a given temperature gradient, the shear of the geostrophic wind which is our dVg dP term, is twice as large. And that is just owing to this low Coriolis parameter. And so our thermal wind balance is enhanced because of low values of Coriolis. In addition, typically around this region, we have ridging. And again, our jet becomes enhanced on the north side of subtropical highs owed to the fact that it is super geostrophic in those regions. And so our subtropical jet streams are a nearly continuous, over time and space, jet stream that is associated with small temperature gradients but have strong shear because of their latitude of origin, where we can have, for a given temperature gradient, twice as much shear at 20 degrees north than at 40 degrees north. And typically being on the north side of subtropical ridges, further enhancing those jet streams. And so that's our subtropical jet. When we're looking at daily weather maps, we cannot really adequately distinguish the subtropical jet and are probably seeing combinations of subtropical and polar jet streams interacting with each other. That's it for this video. We'll talk about low-level jets in another video.